Today we will talk about higher order derivatives and implicit differentiation. At the end of this lesson, you should be able to determine higher order derivatives of functions. And if a function is given in the implicit form, for you to determine its derivative using implicit differentiation. In the past lessons, given y a function of x, we determine the derivative dy dx. This is what we call the first order derivative of y with respect to x, denoted by f prime or dy dx. If the derivative of some function is also differentiable, then we can differentiate this with respect to x and define what we call a second order derivative of the function with respect to x, denoted by f double prime. Again, this is just the derivative of the first derivative of y with respect to x. The third derivative of f, or f triple prime, is the derivative of the second derivative of f with respect to x. In general, the nth derivative of f with respect to x, denoted by f to the n, or you have this notation in terms of the Leibniz notation, is defined the derivative with respect to x of the n minus 1 derivative of y with respect to x. Or, as we said earlier, this is just the derivative of the n minus 1 derivative of f with respect to x. Okay, here are the notations that we can use to denote first derivative of y with respect to x, to denote second derivative of y with respect to x, or in general, to denote the nth derivative of y with respect to x. The notation that uses dy dx or the d dx notation are said to be notation using Leibniz notation. Okay, let us work on some examples. For us to find all the non-zero derivative of the function y equal to 6x to the 5th minus 5x to the 4th plus 20x cubed minus 3x squared plus 10x minus 5. In differentiating this function, we will be using these rules on differentiation. So for the first derivative of y, we differentiate this expression with respect to x to give us 30x to the 4th minus 20x cubed plus 6x squared minus 6x plus 10. Now I hope you are able to follow how we come up with the following terms. Y double prime is obtained by differentiating y prime with respect to x. So we differentiate this expression with respect to x to obtain 120x cubed minus 60x squared plus 12x minus 6. The third derivative is obtained by differentiating with respect to x the second order derivative of y with respect to x, obtaining a 360x squared minus 120x plus 12. And as to the fourth derivative, that will just be equal to 720x minus 120 obtained differentiating this expression with respect to x. With the fifth derivative equal to 720, that being the derivative of the fourth derivative with respect to x, then we stop with this because we expect that when we differentiate the constant 720 with respect to x, we end up with 0. But since what is required is the non-zero derivatives of the function, then we go up to the fifth derivative. Now please take note that for polynomial functions, the nth derivative of an nth degree polynomial whose leading term is a sub 0 times x to the n is always a constant equal to a sub 0 times n factorial. You can verify that 720 is just the product of 5 factorial with 6. Let us have another example, this time to determine the second derivative of y with respect to x of the function y defined equal to x divided by 1 minus x. The rules on differentiation that we are going to use are as follows. So for the first derivative, we will use the rule to differentiate a quotient or a ratio. So that will be given by number 1 formula. Hence, we have the denominator 1 minus x times the derivative of the numerator, which is 1. That is just the derivative of x with respect to x. Minus x times the derivative of 1 minus x, which is negative 1. This difference to be divided by the square of 1 minus x. Simplifying the numerator, the first derivative of y with respect to x is just equal to the reciprocal of the square of 1 minus x. To obtain the second derivative of y with respect to x, all we have to do is to differentiate the first derivative of y with respect to x, again with respect to x. So, with this, we will again apply the rule on differentiating a quotient. Hence, the second derivative of y with respect to x is now given by 1 minus x quantity squared, that is the denominator of this expression, times the derivative of 1, which is 0, minus 1 times the derivative of 1 minus x squared, giving us a 2 times 1 minus x times negative 1, the derivative of 1 minus x. This is the result of applying number 2 rule. Okay, the denominator now will be the square of 1 minus x. So that from here, the second derivative of y with respect to x is just given by 2 times 1 minus x divided by the 4th power of 1 minus x, which you can simplify further to 2 divided by the cube of 1 minus x, dividing both members of this fraction by the common factor 1 minus x. For the purpose of finding the derivative of a function, we may work with the implicit form of the function, capital F of xy equal to 0, or the explicit form of the function, y equal to f function of x. To determine the derivative of the function, it is not necessary to work always with the explicit form of the function, because even with the implicit form of the function, you can determine the derivative dy dx using implicit differentiation, the steps of which are as follows. First is to differentiate both sides of the equation with respect to x. When we do this, we have to take note that y is a function of x. Then we combine all the terms with dy dx on one side of the equation for the purpose of solving dy dx. Let us now work with a particular example to illustrate the use of implicit differentiation. We will be making use of these rules for differentiation, and that we would like to determine the derivative dy dx given the function x cubed y minus xy cubed is equal to 100. As we said, the first step in differentiating a function implicitly is to differentiate both sides of the equation. And in differentiating the left member, we have that equal to the derivative of x cubed y minus the derivative of xy cubed. And the derivative of x cubed y is obtained using the product rule for differentiation. So we have there x cubed times the derivative of the factor y given by y prime plus the factor y times the derivative of x cubed, giving us 3x squared. For the second term, the derivative of xy cubed would be equal to x times the derivative of y cubed, which is given by 3y squared y prime. And as to the second term, we will have y cubed times the derivative of x, which is 1. On the right is 0, being the derivative of the constant 100. So this expression or this equation here is simplified as follows. We have x cubed y prime plus 3x squared y minus 3xy squared y prime minus y cubed is equal to 0. And if we are to isolate the terms with y prime, we come up with this expression, and solving for y prime would give us the ratio of y times y squared minus 3x squared divided by x times x squared minus 3y squared. In summary, higher order derivatives are determined by differentiating preceding derivative again with respect to the independent variable. That is, the nth order derivative of y with respect to x is the derivative with respect to x of the n minus 1 derivative of y with respect to x. And that for the purpose of differentiating a function, we can work with the explicit or the implicit form of the function. Okay, that will be all for today. See you in the next lesson.